103 with Mrs. Meyer, the greatest math teacher of all time.
9, 10.
Okay, so they're still weird. We established that concept.
15.
16. Jessica. 18.
Enough. You need to be able to hear what I'm saying.
21. 22. This is why I'm getting mad at Dylan again.
Okay, as you can see from the incredibly lengthy title, we are looking to basically do the derivatives, or actually the integration of our special functions that we all already know and love.
Going way too hard on a Friday.
It fell on Friday, and we learned it on Friday. Okay, we already talked about these already. What's the integration of e to the x?
Yeah, Jessica, don't forget about your soap opera. You have 2 quizzes coming.
Phenomenal.
Are we legal to tell her that?
Yes, I was going to tell her that anyhow. Okay, what's the integration of 1 over x?
They're like worth 80 points each. No big deal.
Hush. Natural log of x. Thank you. Absolute value. Let's see. And then the one I'm going to be semi-shocked if you remember. We learned how to take the derivative of a number to the x power. And I actually will ask you that one first. What was the derivative of a number to the x power? And that was correctly done by, actually, the log of the number times the number to the x.
Ashley, the bullheader.
Okay, so if that's what you get when you do the derivative, can you all envision what's going to happen when you reverse it?
No.
If you multiplied by the log in this one, yeah. When you do integrate it, you'll actually end up with 1 over the log of the number. You'll end up dividing. And then you'll get a to the x again plus b. Okay, does that seem semi-logical?
You're lying. That's a really hyper.
That's because Dylan had the markers open.
Dang it, Dylan.
Leave it all on Dylan. Put the fan on.
Okay, so the marker is still open. Can we go back to the topic at hand?
That would have been my fault.
Well, the good news is you can still do U substitution with these kind of functions as well. Yeah. So let's see if we can envision what you do. It's not exactly difficult. If I give you x times e to the 5x squared dx, okay, our rule for integrating e to the x says what has to be in the power? X. You have to have a single variable up here. You can't have a quantity. You can't have a 2x. It's got to be e to a variable. So we can't have 5x squared up there. Are we done yet?
We're having back the conversation.
I noticed. So what am I going to use substitute for? The 5x squared. You have to have a single variable in the power. So same old stuff. You're going to do your derivative, get 10x. So when I actually substitute all that in, I will have x times e to the what power? E to the u. And then this will become, when I solve for dx, du over 10x. And so therefore my x's cancel. And what would you like to do with the 10? Pull it out front as a what? As a 1/10. E to the u. And then what is that incredibly difficult integration of e to the u? E to the u. Blows you away. So you'll end up with 1/10 e to the u. Is that an acceptable final answer? We got to put u back in. If you started in x's, you got to end in x's. So we would need 1/10 e to the 5x squared plus b. And there was a massively difficult integration of an e. No. No, the hardest problem's on your assignment.
Oh, thanks. Appreciate it.
Thank you.
Oh, we may end up doing it in class, but we'll see. Y'all have to take the challenge. See if you can figure it out. I don't need more. I just don't need more weenies. I already had weenies in computer app yesterday.
Put more on.
Yes. But. All right, let me ask you all this question. 5. We're on 1.
Oh. We're doing it very
It's gonna be a long class.
Oh.
Jessica fell the corner.
Stop this.
You dropped Jessica.
We are doing this. All right. For your information, the microphone fell down is why they're going ballistic.
You chose to record on a Friday.
What other choice do I have? All right. I'm integrating e to the tangent y over cosine squared y. So, that's kind of weird. I got a tangent in my exponent, but I got a cosine squared on the bottom. Whatever will I do? You can't. You got to do the power of e because you just cannot have that any other way. So you've got to do the tangent y, which the derivative will give us a what? A secant squared y dy. Are you asking why or did you say why?
Can't we make secant into 1 over cosine though?
Yes, we can, Dylan.
See, Dylan figured something out. Yeah.
Because I would have e to the u, and since I see that I already have a cosine, you can actually change it either way. You've got a cosine squared on the bottom here.
And,
That's a secant squared.
well, you see, make the secant 1 over cosine, and it'd be all on the bottom, so you can cross out the cosine.
So, yeah, so he's saying with our fundamental trig identity, secant is 1 over cosine squared. So therefore it would flip over and it would be on top. So you would actually have, when you place dy, you would have cosine squared y times du. Yes, and I'm running out of space, sorry. And then, yes, your cosine squared will go. So there's a prime example of why one needs to know one's trig identities. They become useful. They get you out of trouble.
Kaylee's squeaking.
So now, what do you actually have left to integrate? You just have e to the u, which is e to the u, which is e to the u plus c, or in our case, e to the tangent y plus c. I'm glad you think so.
Why don't we do this quiz?
Kaylee,
Kaylee's
trying to
really
figure out
good.
what you
Trust me, honey, it's going to get more interesting.
I did it.
It's easier than trying to figure out what you pull out of the
Self-improvement starts with self-control.
Okay. We just decided moments ago, we're moving to a to the x now, that we could do the integration of it by doing 1 over natural log of a times a to the x, so that's c. So I just want to do basic simple here. If I said integrate for me 13 to the x power, can you just apply this rule? What do you get? 1 over the natural log of 13 of 13 to the x plus c. No, they get a little trickier, but not a lot. So to make that a touch more interesting for you, suppose I throw in there 3x to the 5th times 7 to the x to the 4th power dx. Now, what do I do? Hold it. I think I miscopied that. That's x 7x to the 6, sorry. Otherwise, this isn't going to work.
The 3 and the 6 are going to cancel.
So you are, by taking out, you're saying you substituting it? So she's saying we should use substitute x to the 6, which would give me
X to the 5th.
du equals 6x to the 5th dx.
Yes! I figured it out.
And then what?
You cancel out the x to the 5th.
So I would have du over 6x to the 5th. And so if I sub that in, that would be 7 to the u times du over 6x to the 5th.
Alright, and the x to the 5th cancels.
Yeah.
And the 3's turn into...
X to the 5ths are gone. 3 goes into 6 2 times. So we really have just 1/2 integration of 7 to the u. And then I need to actually integrate it. You have not done the integration yet. So what is the rule? It's 1 over the natural log of 7 times 7 to the u. Now, what do I do with the 2 in the natural log of 7? You can times them. They will actually leave it as 2 times natural log of 7 on the bottom, but you really could plug that up and make it natural log of 49 if you wanted to.
Nah.
Okay. And I have to put my u back in, which would be x to 6. So these exponential functions aren't that hard. That's because it's not a rectangle.
It's a squiggle.
Squiggle box.
Okay. Can I proceed?
Yeah.
I've got one.
We might make it. All right, I'm changing. It's no longer an exponential function. Now, what are you going to do? It's just a fraction. How do I bring the bottom up with 2 terms?
The negative first.
You're kind of right, but you don't want to take it to the negative first. Because if you integrate something to the negative 1 power, when you add 1 to the power and divide by the power, you get 0. Yeah, it's a natural log. That's not there's no power on the bottom. So we need this to just become a something over u.
Take out the 1 minus x cubed.
So yeah, you take out the 1 minus x cubed, which would give you a negative 3x squared dx, which means I would get a du over negative 3x squared. Is that good news? Yeah, because we got an x squared on top, and now I have an x squared on the bottom with which to cancel. So goodbye, x squared.
Negative 1/3 u.
So negative 1/3 out front, still a 1 over u on the inside. And what do you get when you integrate 1 over u?
Natural u.
You get a natural log.
With, put the u in absolute value.
Yes. U in the absolute value. And you're done.
No, I put u back in.
Yeah. So I would have natural log of 1 minus x cubed plus c. Piece of cake. I love it. They're a piece of cake.
What's my piece of cake?
I like
Stop the video. She's at 14. She's at 18, 19, 20, 21, 22,
Oh,
23,
yes. We need to
24,
stop the video here.
26, 27.